This lesson will cover the following topics: the overall adjustment operation, activation of the air conditioning, attaining and maintaining the required comfort. Let us begin with the general adjustment principle in manual and automatic modes. To attain the desired level of comfort in manual or automatic mode, the user begins by using the temperature adjustment buttons. If the user requests automatic management of the air conditioning by pressing the Auto button, the system adjusts the different parameters on its own to attain and maintain the comfort selected. In the case of manual air conditioning, the user alone is responsible for the controls. The user starts and stops the air conditioning. The user adjusts the temperature control several times to attain the desired level of thermal comfort. The user controls the ventilation speed, air distribution and recirculation independently. We shall now introduce the overall operation for the automatic adjustment of air conditioning. In automatic mode, only the following functions are activated by the system: starting or stopping the air conditioning, ventilation speed, air recirculation management, air distribution, and air temperature. The automatic adjustment system functions are as follows: activating or not activating the air conditioning, heat processing the air and distributing it in the passenger compartment, maintaining the requested temperature, adjusting the air conditioning according to exterior conditions, and stopping the air conditioning. Generally, when the temperature requested by the user is higher than the exterior air temperature, the system adjusts the air conditioning without starting the air conditioning. When the temperature requested is below the exterior air temperature, the system can activate the air conditioning or not. We shall now introduce the different components of the automatic adjustment system. The automatic adjustment system is comprised of sensors, computers, and actuators. The sensors detect physical units and transform them into electrical signals. The computers send signals to the air conditioning computer. The air conditioning computer receives the signals from the sensors and other computers, analyzes them according to its mapping, and controls the actuators. The actuators carry out the actions requested by the computer to attain the level of comfort requested. The sensors that send signals to the air conditioning computer are the following: the external temperature sensor, the passenger compartment temperature sensor, the refrigerant pressure sensor, the evaporator temperature sensor, the toxicity sensor, the humidity sensor, the output sensor, depending on the vehicle, and the solar radiation sensor. The user's instructions are transmitted to the air conditioning computer via the control panel. The air conditioning computer also receives signals from the following computers: the injection computer, the ABS computer, the airbag computer, and, depending on the vehicle, the engine switching and protection unit, or UPC, and the passenger compartment central unit, or UCH. The air conditioning computer controls the actuators to attain the level of comfort requested. These actuators are as follows: the compressor electromagnetic clutch, the compressor electric control valve, the cooling fan assembly, the passenger compartment heating resistors, the rear screen and de-icing rear view mirrors, the passenger compartment fan, the distribution components, the division components, and the recirculation components. The manual adjustment system operates differently in some ways to the automatic system. The main sensors of the manual adjustment system are the user's manual commands. These manual commands activate the different actuators for the air distribution functions in the passenger compartment directly. In manual mode, the injection computer is only involved in managing the cold loop and additional heating. The operation request for the air conditioning will only be taken into account if a ventilation speed is triggered. In this section, we covered the following points. To attain the desired level of comfort in manual or automatic mode, the user begins by using the temperature adjustment buttons. In automatic mode, only the following parameters are affected by the system. When the temperature requested is below the exterior air temperature, the system can activate the air conditioning. The automatic adjustment system is comprised of sensors, computers, and actuators. The sensors send signals to the air conditioning computer. The air conditioning computer also receives signals from other computers. The air conditioning computer controls the actuators to attain the level of comfort requested. The main sensors of the manual adjustment system are the user's manual commands. We shall now introduce the principle of automatic air conditioning activation. As soon as the air conditioning computer receives the auto button pressed signal, it supplies the display instruction to the control panel. If the activation conditions for the air conditioning have been met, the air conditioning computer requests authorization from the injection computer. Once the authorization has been given, the air conditioning computer and injection computer send a command to the UPC, which controls the compressor clutch and engine fan. When a vehicle has no UPC, the engine fan is still controlled by the injection computer via relays. However, the compressor clutch is controlled either by the injection computer or the air conditioning computer or an electronic unit. A passenger compartment ventilation speed, controlled by the air conditioning computer, must be engaged to activate the air conditioning. We shall now look at the way in which the air conditioning computer decides whether to run the air conditioning. Depending on the vehicle, the air conditioning computer receives signals via the multiplex network or via wire connections to the following sensors. The CTN type internal temperature sensor is located in the base of the interior rearview mirror. The CTN type external temperature sensor is located in the base of the right-hand side exterior rearview mirror. The switch to activate or switch off the air conditioning is located on the air conditioning panel. The piezoresistive type refrigerant pressure sensor is usually located on the condenser. The air conditioning computer analyzes the temperature inside the vehicle and the temperature requested in order to activate the air conditioning if necessary. The air conditioning computer also uses the information from the refrigerant pressure sensor. The air conditioning can only be engaged if the pressure in the cold loop circuit is greater than 2 bar and less than 27 bar. Following this analysis, the air conditioning computer either requests or does not request authorization from the injection computer. The injection computer triggers the air conditioning subject to the following conditions. The engine temperature is below the engine overheating threshold. The engine is not running at maximum power and has no major faults. The authorization to run the air conditioning is then transmitted to the air conditioning computer and the UPC if the vehicle has one. Once the computer has authorized the air conditioning to start, it controls the relay or UPC. The relay or UPC then supplies the electromagnetic compressor clutch. The engine cooling fan is triggered at the same time as the compressor clutch to help the compressed gas to condense. Let us look in detail at the way it is controlled. When the vehicle has a trigger sensor, the sensor directly activates 1 or 2 ventilation speeds, depending on the engine temperature detected. When the vehicle does not have a temperature switch, the injection computer analyzes the signal from the engine temperature sensor and refrigerant pressure sensor. Based on this analysis, the injection computer controls 1 or 2 fan speeds. Depending on the ventilation power required, the injection computer then controls the relays that supply the cooling fan assembly. After seeing how the air conditioning starts in automatic mode, let us now look in detail at how it starts in manual mode. In manual mode, the air conditioning is mainly managed by the injection computer. In manual mode, when the user controls the air conditioning by pressing the AC button, the control panel sends a request directly via a wire track to the UCH or injection computer, depending on the vehicle type. If the request goes first to the UCH, it is transmitted to the injection computer via the vehicle's multiplex network. The injection computer only authorizes the compressor to start if the user has switched on a ventilation speed. Once the authorization has been given, the injection computer, or UCH, controls the compressor clutch and the passenger compartment fan power modules. The passenger compartment fan power modules adjust the voltage on the motors according to the user's instructions. In this section, we covered the following points. In automatic mode, the air conditioning is activated by the injection and air conditioning computers and by the UPC, depending on the vehicle. The air conditioning computer analyzes the temperature inside the vehicle and the temperature requested in order to activate the air conditioning, if necessary. The air conditioning computer requests authorization from the injection computer to start the air conditioning. The engine cooling fan assembly is engaged at the same time as the compressor clutch. In manual mode, pressing the AC button sends a direct request to the UCH or injection computer via a wire track. Let us now look at attaining and maintaining the required comfort. With automatic air conditioning, the temperature varies slightly around the user's set value, then stabilizes at a value depending on the exterior temperature. To obtain the comfort level requested, the automatic adjustment system follows the following steps. Blown air temperature instruction calculation. Cold production adjustment according to the blown air temperature instruction. Air heating, cooling to attain the blown air temperature instruction. And distribution of air in the passenger compartment. Let us first look at the blown air temperature calculation. The blown air temperature instruction depends on the following parameters. The user's temperature instruction. The inside temperature. The outside temperature. And the coolant temperature. To obtain the thermal comfort level, the difference in temperature between inside and out should not be too significant. The air conditioning computer uses its analysis to detect a requirement for a hotter or colder blown air temperature in relation to the user's heating control. We have seen how the compressor starts. Let us now look at how the system controls flow from the compressor to regulate cold production. The system can automatically regulate cold production when it is fitted with a variable capacity compressor. In automatic mode, the system cools the air just enough not to have to heat it. This minimizes the power consumed by the compressor, which reduces the overconsumption of fuel. Let us start with the electrically controlled variable capacity. This is processed by the following components: the compressor control valve, the air conditioning computer, the evaporator sensor, and the refrigerant pressure sensor. The evaporator sensor is a CTN-type sensor located within the evaporator. Its role is to inform the computer of the air temperature to prevent the evaporator from accumulating ice. By controlling the position of the control valve, the computer adjusts the capacity to regulate the refrigerating power to the user's request for cold air. We shall now look in detail at the control of the electric control valve of a variable capacity compressor. The air conditioning computer calculates the power absorbed by the compressor using the information from the refrigerant pressure sensor. The computer also analyzes the evaporator temperature. Depending on the blown air temperature instruction, the computer uses its analysis to detect whether to increase or decrease the compressor flow. The computer then controls the electric control valve. This command is carried out via a pulse-modulated current, and the capacity will relate to the cyclic ratio of this signal. The control valve receives the command signal and controls the variable capacity compressor. The control valve imposes a pressure differential corresponding to a variable plate position. We shall now look in detail at the control of the pneumatic control valve of a variable capacity compressor. As for the electric control valve, the capacity is modified by varying the angle of the oscillating plate, which causes the piston travel to increase or decrease. The angle of the oscillating plate develops according to low pressure. The control valve is not therefore managed by the air conditioning computer. The pressure of the circuit causes it to move. When the low pressure rises, the control valve opens to balance the casing pressure with the low pressure. Under these conditions, the angle of the oscillating plate becomes greater, and the capacity increases. When the low pressure becomes lower than the casing pressure, the control valve closes. The capacity reduces even more. Let us now look at how the automatic adjustment system heat processes the air to attain the level of comfort requested. The computer controls the motors that activate the mixing flaps according to the blown air temperature instruction. The computer determines the position of the mixing flaps by interpreting the self-induced current or voltage values created by the rotation of the motor armature. Two supply wires are used to control these motors by polarity inversion. Each motor simultaneously activates two flaps via a linked mechanism. This mechanism enables the hot mixing flap to close when the cold mixing flap is open on the relevant side of the passenger compartment. Depending on the vehicle type, each motor may be associated with a copy potentiometer to measure the voltage and communicate the flap position to the computer. Depending on the vehicle type, the flaps are automatically reinitialized when the ignition is switched on or off. The system or user adjusts the ventilation speeds to obtain the desired airflow. Let us look in detail at the control of the passenger compartment fan. Depending on the vehicle type, the passenger compartment fan is supplied by one or two power modules. For one-zone ventilation, vehicles can be fitted with a resistance power module or an electronic power module. In the case of multi-zone ventilation, vehicles are fitted with two power modules. There are two types of configuration. Either the vehicle is fitted with a 4-pole passenger compartment motor and two electronic power modules, or the vehicle is fitted with 2x2-pole passenger compartment motors. In this case, the front motor is supplied by an electronic power module, and the rear motor is supplied by a resistance power module. Let us look in detail at the control of the passenger compartment fan according to the type of circuit power module. For a resistance power module, a rotary switch connected to the control panel is used to supply the circuit with resistors fitted in series. If the first speed is engaged, the current crosses the three resistors. If the second speed is engaged, the current crosses two resistors. If the third speed is engaged, the current crosses one resistor only. Let us now look at an electronic power module. The air conditioning computer sends a pulse-modulated current type signal to a power module. The power module then supplies the passenger compartment fan motor with a direct current. For a 4-pole passenger compartment fan motor, two of the blades receive a positive 12-volt supply. The power modules adapt the voltage to the other two, in accordance with the instruction from the air conditioning computer. The two types of power module are cooled by circulated air from the passenger compartment fan via cooling fins. Let us now look in detail at the control of the air distribution components when the air conditioning starts. Depending on the vehicle type, the air conditioning computer manages the control of the air distribution flaps via between 1 and 3 direct current motors. Front vent distribution motor, footwell vents distribution motor, and rear headrest vents distribution motor. These motors are controlled by polarity inversion. Each motor simultaneously activates two flaps according to the air distribution selected. The distribution flaps are activated in the same way as the mixing flaps. Depending on the initial position of the flaps and the signal received from the interior temperature sensor, the computer controls the motors activating the distribution flaps. We shall now introduce the specific features of manual mode for attaining and maintaining the required level of comfort. The adjustment of cold production in the compressor can be managed electrically by the air conditioning computer without automatic mode being activated. On vehicles with no automatic air conditioning adjustment, the production of cold can only be adjusted if the compressor is pneumatically controlled. Cold production does not vary with a fixed capacity compressor. In manual mode, the mixing and distribution flaps are controlled by wires or an electric motor. The user directly adjusts the temperature and distribution of blown air until the desired level of comfort is attained. The passenger compartment fan speeds are activated via a switch. The computer activates the fan speed and the distribution components to maintain the flow of air in each row or to follow the driver's instructions. In this section, we covered the following points. The air conditioning computer analyzes the signals and detects a blown air temperature requirement. The system can automatically regulate cold production when it is fitted with a variable capacity compressor. Depending on the blown air temperature instruction, the computer commands the control valve, thereby affecting the compressor flow. The control valve for a pneumatic capacity compressor opens or closes according to the low pressure. The computer controls the mixing motors according to the initial position of the flaps and the blown air temperature instruction. Depending on the vehicle type, the passenger compartment fan is supplied by 1 or 2 power modules. The power modules are electronic or resistance type. According to the internal temperature, the air conditioning computer controls the motors that activate the distribution flaps.